Hello and welcome to the pre-lab video for the neutralizing power of antacids experiment. This is an experiment that's part of the General Chemistry 1 sequence at York College of Pennsylvania. The goal of this particular exercise is to determine the cost effectiveness of a group of antacids using the acid-base titration procedure. Now you'll work as a group or part of a team to accomplish this goal, because we have several antacids to consider, and each student and their partner, or each pairing, will work with just one antacid, and then as a class you will combine all of your data to consider which of the antacids in the group is the most cost effective. Now we're going to define cost effectiveness as the moles of acid reacted or eliminated by the antacid per dollar spent on the antacid. So we'll need some information which is available in your laboratory manual for the costs of these antacids and then their dosages as well. So as an example of how we would accomplish this, let me walk you through some of the pre-lab questions and some of the reactions that are involved in this experiment. If we consider rolates, a very common commercially available antacid, if you read the package, it tells you that a tablet of your standard rolates, and nowadays there are several different varieties, but one of the versions of rolates tells you that every tablet contains 550 milligrams of calcium carbonate and 110 milligrams of magnesium hydroxide. Both of these are basic materials. They have bases in them that will react with acids. Thus they are, antacids. They're going to eliminate excess stomach acid that might be generated in your stomach through different foods that you might be eating. Okay. So how many moles of active ingredients is this in our antacid tablets then, or in a single dosage actually? Because a dose of rolates is 3 tablets. So this is 550 milligrams per tablet, but 3 tablets is 1 dose. So you would have then 1,650 milligrams of calcium carbonate when you take a dose of rolates, and you would have, again, 3 tablets or 1 dose. So you would have 330 milligrams of magnesium hydroxide when you take a dose of rolates. Okay? But these are the gram amounts, so we can convert these to moles, because we'll need to do that when for considering the reactions, right? Reactions and their coefficients and their quantities are always considered from a mole perspective. So first I've got to get rid of the milligrams. 1 gram is 1,000 milligrams. And then for calcium carbonate, a mole of calcium carbonate is 100.9 grams. It looks like, or 0.9, sorry, 100.09 grams. So a dose of calcium carbonate, or of TUM, sorry, contains 0.0135 moles of the calcium carbonate. The magnesium hydroxide, on the other hand, again, 1 gram is 1,000 milligrams. It has a different molar mass. A mole of magnesium hydroxide has a molar mass of 58.3 grams. So that means that a dose contains just 0.00566 moles of magnesium hydroxide. Now if we add these two together, our entire dose contains 0.0192 moles of, quote, active ingredients. Okay? And that term active ingredients is referring to these are the materials that act or actually do something when you ingest your tablets of Rolaids or any other antacid. So those are the compounds that are going to react with the hydrochloric acid. Okay? This is actually the first question in your pre-lab for this exercise, was to determine how many moles of active ingredient are in a dose of Rolaids. So we see it's 0.0192 total moles. Okay? Now, how many moles of acid can be eliminated by these active ingredients depends on the reaction that each respective active ingredient has with hydrochloric acid. So if we look at the balanced equations, and again, these are available in our laboratory manual, it takes 2 HCl's to react with 1 calcium carbonate, okay, to form calcium chloride, and then water and carbon dioxide, CO2. Okay. This is actually a gas-forming reaction, one of the patterns that we study in Chapter 4, just so to link to that earlier this semester. Okay. So it's a 1-to-2 ratio. So our 0.0135 moles of calcium carbonate can eliminate double that many moles of hydrochloric acid, or 0.0270 moles of HCl. Okay. And then on the magnesium hydroxide side, well, it's actually a 1-to-2 ratio here as well. It takes 2 HCl's to eliminate a magnesium hydroxide, forming MgCl2 and 2 waters in this case. No gas being formed in this reaction. But our 0.00566 moles of MgOH2 times the 2 moles HCl per mole of MgOH2 should produce or eliminate 0.0113 roughly moles of HCl. Thus, the total moles of HCl that are eliminated is simply the sum of these two numbers. So that's going to be 0.0383 moles of HCl. So that's the answer to the second pre-lab question that we have for the number of moles of HCl that can be reacted or neutralized by a dose of Rolaids. And that tracks directly from the first answer that we had down here as well. Okay? Okay, the third pre-lab question then asks us to take the moles neutralized and turn that into the cost effectiveness of our antacid. This is just really a unit conversion, although we do have to couple in the costs of our materials. So we'll begin question 3 with the 0.0383 moles neutralized per dose. Okay? Again, this up here is really per dose. So that becomes when we had per, that implies a denominator or a division. So we got moles of HCl eliminated per dose. Okay? Well, now we want to figure out how many moles this is per dollar that we would spend. Okay? So we need some information from the Rolaids package. Okay? How many tablets it contains, or how many doses it contains, and what the cost is, really. Okay? So I'm actually going to go backwards and eliminate the dose and go to 1 dose was 3 tablets. Okay. So I now have how many moles are eliminated per tablet. Seems like I've gone backwards. But the reason I'm doing that is because the package tells me how many tablets it contains. The package of Rolaids that I was looking at contained 150 tablets per the package. So now I've got how many moles are eliminated per the package of Rolaids. And if I know how much that costs then, one package, in this case costs $4.99, or roughly $5, that would tell me the moles that are eliminated per dollar spent. Okay? I don't have my calculator handy on me, but you should be able to run these numbers through. Essentially, you're multiplying by 50 divided by 5, so you're really just multiplying by 10. I would think your answer should come out to be approximately 0.383 moles per dollar. Okay? And that should be the cost effectiveness. This is the theoretical cost effectiveness of Rolaids. Okay? As part of your lab work today, you'll need to calculate the theoretical cost effectiveness for each of the antacids that are included in a table that you'll find in your laboratory manual. So that would include Rolaids, which we've already got done then, the Tums antacid, Mylanta, Malox, and milk of magnesia. And each of those antacids has its active ingredient information contained in a table in your laboratory manual. So you'll need to mimic the pre-lab series of questions that we just did for each of those. Tums is very similar. It has only 500 milligrams of calcium carbonate, so you can use the calcium carbonate reaction that we just did right here to work your Tums. Mylanta contains magnesium hydroxide, so you can follow the magnesium hydroxide portion of the work that we did, but it also contains aluminum hydroxide. Aluminum hydroxide is AlOH3, so it'll take 3 HCl's. So you'll want to write that reaction and utilize that when solving for Mylanta. The Malox is similar to Mylanta in that it contains the same ingredients as Mylanta, magnesium hydroxide and aluminum hydroxide, in the same quantity. So they should have the same theoretical neutralizing capacities. Okay? And unless their dosages are different, I'm sorry. And then lastly, milk of magnesia contains only the magnesium hydroxide. So you've really used or seen all of the reactions, except for the aluminum reaction, aluminum hydroxide, that you'll need to calculate those theoretical neutralizing capacities. Okay. Let's talk about how we're going to experimentally determine the neutralizing capacity of an antacid. We first need to establish the strength or how much acid might be present. So we have a mock solution of stomach acid for you to work with in the lab. Stomach acid really is nothing more than hydrochloric acid, right? And you're going to determine the concentration. So you'll do a standard acid-base titration between sodium hydroxide and hydrochloric acid to come up with the moles of HCl that are eliminated. You're going to be using your NaOH that you created a few labs ago, or a previous lab when you did an acid-base titration. So you already know its concentration, and thus by tracking in a titration, you can determine the concentration of the HCl via the titration. This is a 1-to-1, so it'll be very appropriate to use our MAVA equals MBVB to help you calculate the molarity of your acid. Okay? Once you know the molarity of the acid, you will basically create a big pile of acid molecules. Okay? This will be generated by having, I believe it's 3 aliquots, or 3 25 milliliter pipettes of the hydrochloric acid. Now we're going to eliminate or react all of this acid. Okay? Once you know its concentration, you know how many moles of acid there are here, total. Okay? You know the total moles because at that point you'll know the molarity and you'll know the volume. Okay? So you know the total moles of HCl in this pile up here. Okay? It's the molarity of the acid times the volume that you added into it. You will then add the antacid to it. The antacid will dissolve or react away a large portion of it, eliminating a bunch of it. But some will be left over. How much left over is yet to be determined. We can find the amount left over by a titration. If we do a titration, again with our sodium hydroxide, we can figure out the moles of acid because it comes, even though it's MAVA, it's actually equal to MBVB as well. So the molarity of our base, which we know, times the volume that we add, okay, will tell us how many moles of acid were left over. Where did the rest go? Well, we know the moles initial, but that's equal to the moles that are neutralized by the antacid plus the moles left over. So how will we find the moles neutralized? Simply by subtracting the moles initial minus the moles left over. Once you know the moles that are left over, you would be able to determine how many moles were, once you know how many moles are neutralized, you've determined essentially one of the numbers we were looking at in the pre-lab questions. How many moles are eliminated per tablet, okay? So this would be the moles that were eliminated, in this case by, I believe you're only going to use 1 tablet or 1 teaspoon, so that's not going to be a full dose. And you would then begin the same series of calculations that we were doing in the pre-lab questions, okay? You'll just be arriving at the moles neutralized by an experimental calculation as opposed to theoretically from the package values. Ultimately, you'll take this moles neutralized and turn it into moles per dose by scaling up or down for the correct number of tablets or teaspoons per dose. And then you'll convert to moles per dollar the same way we did in the pre-lab. How many tablets or teaspoons are in the package, and then what was the cost of the package. In the end, you'll be able to compare your theoretical moles per dollar to your experimental moles per dollar. And we'll also be able to just compare all of the antacids as a class by sharing group data and determine which of the antacids eliminates the most moles per dollar. And that could help inform your choice as to which one you might buy. You might be willing to buy a slightly more expensive antacid if it actually is eliminating more moles of antacid per dollar that you're spent, and you're getting a greater cost effectiveness out of it. Okay? So that's the goal of the experiment. This is the last wet lab or wet experiment that we do of the semester for the fall 2012 semester at least. And you will be writing a rather large report for this experiment. It's going to be worth double the number of points a usual paper or lab report is worth, 20 points. And that's because there's a lot of this extra calculation work involved relating to those pre-lab questions, where you have to calculate all of those theoretical cost effectivenesses and have that data. The data template helps you organize all of the calculational work, and that's available in the fact data folder as usual. So I hope you'll make good use of that data template in writing an excellent lab report for this experiment. Okay? So you're working with acids and bases. Everything you generate in terms of waste today can safely be put down the drain, because you'll be neutralizing all of your solutions, acid and base. Your indicator is bromophenyl blue. It is a chemical that will appear yellow when it is in acid and blue when it is in base. So you'll be watching for the yellow to blue transition, as opposed to the phenolphthalein indicator that we used in the benzoic acid titration, which went from colorless to pink. We have a different indicator in this experiment, yellow to blue. Right? The safety concerns that you might have to think about today: you are working with acid and base, so you don't want to splash them around or get them splashed onto your skin or your clothing. They can stain your clothing, and if you have sensitive skin, the acid and the base might irritate your skin as well. Be sure to wear your safety glasses, of course, but otherwise the safety hazards are fairly minimal in this experiment, and this one should go pretty well. When you're done with your experimental work, you will need to complete a portion of your calculations to determine at least your experimental moles neutralized per dose, so that you can share that information with the rest of the class, and that you can get the rest of the class's data, hopefully, before you even leave the lab, so that you can get a head start on writing your lab report. Okay? So good luck with your acid-base titrations and finding out which antacid is the most effective.